Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. My name is Imad Fakat. Today the topic of my presentation is forensic style trace analysis, detection of explosive residues, screening and confirmatory methods. Forensic trace explosive residue analysis. Forensic trace analysis aims to recover and identify microscopic amounts of explosive residues left on surfaces, hand swabs, debris, and soil. After handling or detonation, typical workflow stages included sampling collection, surfaces, swabs, adhesive tape, and vacuum, extraction and pre-concentration, SPME, and solvent extraction, screening analysis, rapid methods to flag potential positives, confirmatory analysis, specific identification, data interpretation and reporting, chain of custody and legal reporting. In forensic lab screening methods prioritize speeds and sensitivity at low concentrations, whereas confirmatory methods prioritize specificity and legal defensibility. Sampling and extraction workflow non-hazardous safe. Surface sampling. First is swab sampling. Dry or solvent wetted swabs are used to collect residues from surfaces, metal and fabric. Vacuum sampling and tape lifts for porous materials or textured surfaces. Effective collection depend on substrate type and intent targets, volatile or semi-volatile residues. This diagram for static in-vision microextraction and dynamic inflow microextension. Principle: a coated fiber adsorbs analytes from headspace or liquid, then the analytes are thermally dissolved into GC injector for analysis. Advantages: solvent-free high enrichment of trace volatiles, minimal sample preparation. Applications: explosive agents, DNMB used as training surrogate and surrogate VOC volatile organic compounds, effective for low vapor pressure compounds when optimized. Extraction techniques. First, solvent extractions. Traditional liquid extractions followed by solid phase extractions. SPE cleanup. Second is TV SPME total vaporization SVPME for complete vaporization of sample before GC analysis higher sensitivity. The third is the cleaning techniques. Screening methods aim to quickly flag surfaces or samples that may contain residues, needing confirmatory analysis. These include: first is ion mobility spectrometry, IMS, rapid sensitive detection of ionic species, nitrate, nitro groups common in explosives, often used in field detectors, airport trace detectors, high false positive risk without confirmation, nitrate background from non-explosive materials, RSC publishing. Rapid GCMS screening approaches, fast GC, rapid GCMS, short analysis time, greater than 5 and less than 20 minutes after SPME sampling to screen volatile profiles. Extracted ion profiles and deconvolution can enhance detection of targets in complex matrices. PUB method. Principal: a coated fiber adsorbs analytes from headspace or liquid, then the analytes are thermally deabsorbed into a GC injector for analysis. Advantages: solvent-free high enrichment of trace volatiles, minimum sample preparation. Applications: explosive agents, DMNB used in training surrogate and surrogate VOC stand for volatile organic compounds, effect for low pressure compounds when optimized. This diagram of SM, custom finished flakes, preparation by precision cut, resin coated chips for adding intense sparkles to custom paints, job, etc. Confirmatory methods, instrumental identification. For legal admissibility, confirmatory techniques provide specific molecular identification. Gas chromatography, mass spectroscopy, gold standard confirmatory test for organics, provides molecular identification via mass spectrometry to libraries Wikipedia. Electron ionization gives reproducible fragmentation spectra for compound identification. SPME, GCMS can achieve low detection limits NG or sub-NG levels with proper optimization PMC. Liquid chromatography mass spectroscopy. For non-volatile thermally labeled residues, HMX, some peroxide-based surrogates. Soft ionization enhanced intact molecule detection PMC. Ion chromatography target inorganic ions, nitrate, nitrite, and some degradation products, often coupled to MS for enhanced selectivity PMC. Kinematrics and pattern recognition. Kinematrics tools PCA, LDA clustering applied to GCMS profiles can classify complex mixtures and differentiate formulations. PMC analytical figures of merit. False positive and false negative. False positive. Common sources environmental nitrate, non-explosive VOC stands for volatile organic compounds and tagant overlap with beginning chemicals. Screening methods IMS color test may flag beginning compound with similar signatures, necessitating confirmatory analysis RSC publishing. Next, false negatives. Thermal degradation in GC may prevent detection. Mg, for example, unstable under high GC temperature PMC. Insufficient sampling instruction can miss low abundance residues. Next, mitigation strategies. Optimize sampling and extraction protocol. Use orthogonal conformation LCMS for non-volatile. Implement robust kinematric classification thresholds. Next is objectives to collect trace residues using forensic swab sampling. Next, to extract and pre-concentrate residues using SPME and solvent extractions to perform screening analysis using GCMS or LSMS with library matching to detect inorganic oxidizer surrogates using ion chromatography to apply kinematric tools PCA, PLS, DA for pattern recognition to evaluate detection limits, false positive and false negatives through prepare etching of custody style of forensic report to understand legal and ethical constraints in forensic explosive analysis, to perform screening analysis using GCMS or LSMS with library matching. Next, materials and chemicals. Which materials used in forensic type analysis? Material 2,4-dinitrotoluene, 2,4-D anti-stand for dinitrotoluene, sodium nitrate NaNO3, sodium nitrate NaNO2, benzoic acid, methanol HPLC grade, acetonitrile HPLC grade, deionized water 80 megahertz. The next purpose 2,4-dinitrotoluene used for purpose organic explosive surrogates. Sodium nitrate NaNO3 purpose ionic oxidizer surrogate. Sodium nitrate NaNO2 ionic surrogate. Benzoic acid matrix references. Methanol HPLC grade extraction solvent. Acetonitrile HPLC grade LCMS solvents. Deionized water 18. The next is notes. Notes 2,4-dinitrotoluene nitroaromatics analytical target sodium nitrate NaNO3 mimics nitrate oxidizer signature. Sodium nitrate NaNO2 analytical differentiation benzoic acid retention behavior control methanol HPLC grade purified for low background acetonitrile HPLC grade high purity deionized water for dilutions and IC. Safety note, all compounds are non-explosive at the scales used but full laboratory PPE, lab coats, safety glasses, nitrile gloves and chemical hygiene must be observed. The next is apparatus which is used in this experiment. Solid phase microextraction SPME fibers. For example, DVB, CAR, PDMS. The next is GCMS system with EI source and spectral library and ISP for example. LGMS system reversed phase separation ESI or EPCI. The next is ion chromatograph with conductivity detector. Analytical balance 0.01 mg per cm. Certified trace clean glass vials with speta. Swabbing kits, polyester swabs, chain of custody forms and evidence bags, vortex mixture and sonicator. The next is pre-analytical setup, surface preparation. Who surface prepared in this experiment? First of all, prepare stainless steel or plastic coupons 10 multiplied 10 centimeter. The next, spike surfaces with diluted surrogate mix. For example, 10 nanogram to 100 nanogram 2,4-D stand for dinitrotoluene plus nitrate or nitride and allowed to dry. The next, chain of custody documentation for each sample record case ID, sample ID, date, time, surface, material, sample and condition. When all things complete in experiment, then we check again and again case ID, sample ID, date, time, surface, material, sample and कंडीशन कि हमने कौन सा सैंपल लिया, उसको कौन सी कंडीशंस में रखा, क्या क्या डेट थी, क्या टाइम था, सरफेस कैसी थी, मटेरियल्स उसमें कैसे थे, सैंपल हमने कैसे हैंडल किया एंड देन लास्ट उसकी में कंडीशंस हमने कौन कौन सी रखी थी. The next is procedure. Surface swab sampling, label swab and evidence bag. Moisten swab lightly with deionized water. Wipe define area using a zigzag pattern, horizontal then vertical. Insert swab into bag, seal and log into chain of custody. Next, extraction. Please place swab tip into 2 ml well and 1500 micro ml methanol water. Sonicate 10 minutes, then vortex 2 minutes. Transfer extract to a clean vial, SPME pre-concentration. Condition SPME fiber per manufacture. Expose fiber to extract headspace for 10 minutes and ambient temperature. Insert fiber into GC inlet for thermal desorption. GCMS screening column. 30 meter multiply 0.2 millimeter 0.25 micrometer film carrier helium at 1 milliliter over minute. Oven 440 degrees Celsius 2 minute, RAM 10 degrees Celsius minute to 280 degrees Celsius. MSEI 7 electron volt scan, mass per charge 40 over 400. LSMS confirmatory analysis column C18RP mobile phase A is equal to 0.1 percentage formic acid in water, B acetonitrile, gradient 5 to 95% B over 10 minutes, MSESC negative. These picture for gas chromatography mass spectroscopy. In this experiment, we use machines, gas chromatography, mass spectroscopy, and another is mass spectroscopy. This is gas chromatography and this is mass spectroscopy. These machines used for this purposes separates organic compounds and identifies them via mass spectral library matching. इस मशीन से हम ऑर्गेनिक कंपाउंड को आइडेंटिफाई करके उनको सेपरेट करते हैं बाय मास स्पेक्ट्रल लाइब्रेरी. The next is ion chromatography. Calibrate for NO3 negative and NO2 negative range 0.1 microgram per liter to 10 microgram per liter. Inject exerts to quantify ionic species in the activate of oxidizers. Then last, detection results. Example results for a contaminated surfaces. GCMS peak at 12.8 minutes matching 2,4-DNT stand for dinitrotoluene match score 91 to 95%. LSMS confirmed 2,4-dinitrotoluene at exposed retention time and mass per charge time in negative mode. ICNO3 is equal to 2.1 microgram per centimeter square. NO2 negative is equal to 0.3 microgram per centimeter square. Chemometric analysis targets swabs clustered distinctly from blanks. Before explaining result, then we come back to these diagrams. Static invisible microextraction will take consist of 4 steps. First, we take a plunger, barrel, needle. SPMI holder, fiber assembly. Then next, these parts convert into polymer coating fused silica fiber. The next second step भी aqueous sample. सैंपल aqueous हो, मैग्नेटिक पार्ट इसमें फिक्स हो, ग्लास जैकेट हो और स्टील पार्ट प्रेजेंट हो और पॉलीमर की कोटिंग हुई हो. The next these part convert into third step thin sheet. Thin sheet coiled thin film present हो, these option linear हो और thin film present हो. This part is also consist of stainless blade, polymer coating, stainless steel, wire mesh. In this diagram, we use all apparatus with a polymer coating and must be SPME holder, aqueous sample, magnetic rod, and thin sheet present. The next diagram, dynamic inflow micro extraction. This The static in vessel microextension all procedure convert in dynamic inflow micro extraction. The part consists of capillary segments. Capillary segment convert into coating, fiber packaging, sorbent packaging, and monolith. These part D convert into SPD. SPDE micro syringes, needles, polymer coating, maps, PMME syringes, all parts used in this process coat with polymer packed sorbent pinhead monilth capillary aqueous sample multiple plate packed sorbent tip. The last result is PMME, MPS, SPD, and coating. The next we move to results of these experiments. Result. In this cumulative forensic trace analysis experiment, non-hazardous surrogates compounds were used to model the detection of explosive residues. Surface web samples were collected from laminate plastic and metal coupons ensuring proper chain of custody documentation. Extraction was performed using a methanol water solvent system followed by pre-concentration with solid phase micro extraction. Screening by GCMS successfully detected 2,4-dinitrotoluene surrogates in sample S01, S02, S03, and S06 with retention times around 12.7 to 12.9 minutes and library matches scores of 89 to 93%, while blank controls S04 and S05 showed non-detectable peaks. LCMS confirmed the presence of DNT in target samples with characteristics ions mass per charge ratio 182 and retention times consistent with standards. Ion chromatography analysis revealed nitrate concentrations of 1.85 to 2.1 microgram per centimeter square and nitrile concentrations of 0.5 to 0.3 microgram per centimeter square in the target sample, whereas blank controls reminder near 0.1 microgram per centimeter squares. In this procedure, basically we observe screening by GCMS successfully detected dinitrotoluene. And we use samples S01, S02, S03, and S06 with a retention time 12.7 to 12.9 minutes and library matches scores 89.93%. But already we discussed about we gain result 5 to 95%, but if we use 604 and 605 show no detectable peaks, that's why we conclude result 89 to 93%. But if you use S04 and S05 and show detectable peaks, then we can observe ATM 5 to 95% results. LS-MS confirmed the presence of DNT in target samples with characteristics ion mass to charge ratio 182 and retention times consistent with standards. Ion chromatography analysis revealed nitrate concentrations of 1.85 to 2.1 microgram per centimeter square and nitrate concentration of 0.25 to 0.3 microgram per centimeter square in the target samples, whereas black controls remainder near 0.1 microgram centimeter square. Calibration curves for both GCMS and IC standards were linear over tested ranges, enabling accurate quantification. Chemometric analysis using PCA and LDA demonstrated for clearing clustering of target samples separate from blanks, highlights the effectiveness of multivariate pattern recognition for discriminating true positive signals from far background noise. The detection limits for GCMS were estimated at 5 to 10 nanogram per swab and for IC nitrate nearly equal to 0.1 microgram per centimeter square. But in case of no false positive were observed, while false negatives were minimal due to standardization, swabbing, and high recovery efficiency 95%. Overall, the experiment successfully demonstrating the integration of sampling, extraction, screening, and confirmatory methods for trace level forensic analysis use safe surrogate compounds, while emphasizing data integrity, legal documentation, and ethical laboratory practices. Trigonometric analysis using PCA and LDI demonstrated clear clustering for target samples separate from blanks, highlighting the effectiveness of multivariate patterns recognition for discriminating true positive from background noise. इसमें हम LSCMS को कंफर्म करते हैं डाइनाइट्रोटोलीन के लिए इस सैंपल्स लेते हैं उसकी कैरेक्टराइजेशन करते हैं मास टू चार्ज वॉल्यूम 182 ग्राम पर रिटेंशन टाइम्स कंसिस्ट विद स्टैंडर्ड और देन आयन क्रोमेटोग्राफी एनालिसिस रिवील करती है नाइट्रेट कंसंट्रेशंस को 1.85 टू 2.1 माइक्रोग्राम पर सेंटीमीटर स्क्वायर एंड नाइट्रेट कंसंट्रेशंस जो है वो 0.25 0.3 microgram per centimeter square in the target sample. Blend control remained near 0.1 microgram per centimeter square. Basically हम इसमें डाइनाइट्रोटोलीन की डिटेक्शन 100% गेन कर लेते हैं if अगर हम यूज करें S01, S02 and S03 and then last S06 S04 and S05 हम इसलिए यूज नहीं करते क्योंकि ये डिटेक्टेबल पीक्स शो हमें नहीं करती अगर ये डिटेक्टेबल पीक्स हमें शो करें तो देन हम 5 to 95% रिजल्ट अचीव कर सकते हैं इफ अगर ये डिटेक्टेबल पीक्स हमें शो ना करें तो हम 89 to 93% नॉन एक्सप्लोसिव या हैजर्डियस मटेरियल्स को की डिग्रेडेशन कर सकते हैं देन लास्ट the detection limit for GCMS were estimated at 5 to 10 nanogram per swab and for IC nitrate at 0.1 microgram centimeter square. No false positive were observed, while false negative were minimal due to standardized swabbing and high recovery efficiency 95%. ओनली हम 95% इसी केस में गेन कर सकते हैं अगर हमारे पास फॉल्स नेगेटिव मिनिमम अमाउंट ड्यू टू स्टैंडर्डाइजेशन स्वैपिंग की वजह से एंड नो फॉल्स पॉजिटिव वर्ड ऑब्जर्व फॉल्स पॉजिटिव हमें कुछ ऑब्जर्व ना हो और फॉल्स नेगेटिव हमें मिनिमल अमाउंट में स्टैंडर्डाइज्ड हो जाए स्वैपिंग हो जाए एंड उसका हाई रिकवरी एफिशिएंसी हो जाए 95%. Overall experiment successfully demonstrated the integration of sampling, extraction, screening, and confirmatory methods for trace-level forensic analysis using safe surrogate compounds while emphasizing data integrity, legal documentation, and ethical laboratory practice. This is the result of my experiment forensic trace analysis. Forensic explosive residue analysis. सबसे पहले हमने सैंपल कैसे लेना है इसकी प्रिपरेशन कैसे करनी है इसको हैंडल कैसे करना है इसमें कंडीशंस क्या रखनी है डेट क्या है टाइम क्या है इफ अगर हम इन सारे कंडीशंस पे सही काम करेंगे हमारे पास रिजल्ट 95 to 95% आएगा this is all from my side this next is references books and reviews articles से ये डाटा लिया गया है this is all from my side thank you Allah Hafiz